Welcome. CMake tutorial. I've lost track on 9. Libraries part 2. Find package. This whole thing right here. That's what we're going to mainly talk about today. Here in this example, I'm going to be finding GLEW because it's not well maintained for Windows, at least not for the Visual Studio compiler. So it's kind of annoying. So I will say right off, if you want to use GLEW on Windows, you either got to go download the binaries and use them directly, or you need to use a different compiler other than the Visual Studio compiler. For the example, let's start with the find library. I'm going to expand on find library a little bit real quick, and then I'll get into find package. And I'm also going to do it on Windows and Linux. So I'm going to jump around a little bit, but hopefully this helps you develop a good understanding of find library, because I basically have spent way more time than I thought I would trying to figure all this out, and mostly because I was going back and forth between platforms. I was like, let's try it on Windows now, that'll be fine. Well, I will go over everything I learned and teach you how to become an expert, or maybe not an expert, but you know, way better than you probably were before since you're watching this video. GLEW. So if you just Google GLEW, you get this site, glewsourceforge.net, and you can get the binaries for Windows 32 and 64. And the latest version, as you can see, it hasn't been updated since 2017. So if you're using GLEW, don't use something else. Use GLAD or something. This is no longer maintained, basically, mainly because it's like specific to OpenGL, and OpenGL is no longer maintained. So, but you can still go get the binaries. So I went and got the binaries, and I'll show you how I did it here with the find library. I put it in development libraries, GLEW, and then this is what it extracts as when you get those binaries. You get the bin, which is like the DLLs, and you get the lib, which is the linker libraries that you need when you're building, and the include directory for GLEW. So, but this does not work with find package though, because find package needs a config.cmake. And those binaries do not come with it. And if you download the latest source and try to build it with Visual Studio, it doesn't work. It's not configured. You have to use an old version of Visual Studio, so it's no good. But with those binaries, you can still get it to work by just pointing to it, and you do have to manually put it in here with paths. As you see, I've manually put it in a path. Then I had to put in some suffixes for it to check down those paths under lib release 64, and also down this. We're good. Alright, so real quick on the find library, just to wrap this up, if you want to use GLEW like we've been doing before, I know a lot of people still try to use GLEW. You do the same things we talked about last time, but now you have to actually put in the paths to it. So that's my path to the root of it, and then I have some suffixes for it to check when it's looking for things. And very good. And then when you link it later, this is required. You could do this whole check thing, make it fail if it doesn't, otherwise you append to the list. So that should make sense to you. Same thing we did before, but now we're just adding right here to our append list that we're going to append at the end. Extra libders, extra includers. You've probably figured out by now that you can do it different ways. Like, since we know it's definitely found here, we could just go ahead and say target link library my GLEW lib. That points to the library. And target include directory. I guess, you know, you have to know where it is and put it in there. So that's a little unfortunate, because that means if someone's downloading it, it goes down here. If someone's downloading it, they're going to have to manually do some of this stuff, and that stinks, because you want people to just be able to clone your software if they're working on it. Well, if it's closed source, and just work on it. You don't want to have to make them figure out a bunch of stuff. So that's basically the point of this, to get it in a way where people don't have to figure out a bunch of stuff. Just use your software. They can just hit the clone button, open it in something. As long as they've got CMake, it'll work. And of course, maybe a few other small requirements, but you don't want to have to get a bunch of specific dependencies and make it all confusing for them. And So that's what find library ends up being in this case. Okay, so let's talk about find package. We're just going to delete all this. This is going to be gone. The dependencies are part of the project. Like if you've copied them into your project and they come with it, then you don't need to do any of this find library stuff. You can just directly link to it and that'll be fine. But these are more modular because, well, they will find it from specific spots. All right, so let's talk about this find package a little bit. So when you use find package, you put in the name of the library and whether it's required or not. There's a whole bunch of other options. If it's required, you don't need to check if it's found because it's gonna stop here. If glue is found if it got here, so you don't need to do required. But if you don't do required, you can do some kind of check and say something happens or something doesn't happen, like else if here, that's the only other case. So you could do a little switch around if it's not required to maybe use the library or not use the library, or implement some of the earlier things about the options of using and linking or not linking, because sometimes libraries are optional to do special stuff. But in this case, we're mainly going to look at whether it's required. Now, there's some more things about this that are a little peculiar, and I'll explain them as I go. One of the big things is you're going to either do this as a module, like so, you just put module in here, or the default is module, but it also, there is config. And if you do it as a config, it needs a CMake, some kind of config for the library. So for example, I'll show you that with GLEW. So I went to GitHub and downloaded the GLEW source code, and what it looked like was like so. Let's see, GLEW. Here's GLEW, and here's what their repo looks like. I think I messed with it some, so it might be a little different, but they have a build, CMake, and a GLEW config.cmake right there. So that's what it needs to know about. That's what it needs to point to if you're doing find package config. And you'll see, like, it doesn't do it here with Visual Studio Code. It's not quite smart enough. But if I open CMake, for example, and I run it on my project, I'm pathed to my project here, and I'm pathed to the build directory, I'm going to go ahead and delete the cache. And I hit configure, let it do its thing. It's going to fail, and that's fine. Let it fail. And then you just got to fill out something. So if this fails and says doesn't find the GLEW dir, GLEW not found, this is what needs to point to that config. However, like I mentioned, it doesn't work on Windows just because the library is out of date. But in general, a library that you clone and build will work. So I'll just show you, for example, go to GLEW here, go to build, go to CMake, or wait a second. Or was that? I guess it was CMake, yeah. And hit configure again. And now it's happy, sort of happy. Well, it's got some other problems. But it keeps this in here. If it didn't find it, like if this directory was wrong and you hit configure, it'll clear back out to not found. It says not found. So if it switches to not found, then it's messed up. But it's invalid because it's not built. It needs to find like all the stuff. But I tried to build it. Like I went to Visual Studio and I opened the latest solution. Let's see, open a project or solution. I looked at their directions. They say basically to go to build and Visual Studio. See, there's no VC16, so they haven't updated it for the latest version. They say use this solution, and it has some errors when you do this. So not a whole lot you can do about that. So seems like if you're using GLEW, you just want to do either the find library or bring those binaries into your project and use them, or just link to them directly. So find package is not so great for GLEW in this case, but this works fine in Linux because you could just sudo apt-get install libglue dev or whatever, and this find package will just work. But okay, the difference between I showed you what the config is. Now I talked about modules, so let's go back to that. So when you say module, it looks for a find module. And what a find module is, well, it looks in your CMake module path, so you gotta set your CMake module path. And this is a folder, so it's a folder right here, CMake module path. And it looks for a file in that module path called find, and the name of the library, and then .cmake. And it has to be specifically that, capital F on find, the exact name of this package thing, then .cmake. So you could do this for anything, which is kind of cool. New file, so you could say find asdf.cmake, and then in your main CMake you could do a let's see, what, a find package asdf, and it'll basically run this thing, and it expects you to set everything. This is where it expects you to do all your work, but some of these are included. A lot of these you don't need modules. The configs come with CMake. So if you look at the CMake documentation, if I Google search find GLEW CMake and just click one of these, you'll see that it's part of CMake, and there's find glut, there's a whole bunch of find basic libraries, and it tells you all about what it does if it finds them. So you might need some other stuff. There's find git, for example. So these are just valid commands as long as you have a version that supports it. And so you can double check here and make sure. Someone mentioned this documentation is not always up to date, but what are you going to do? It's the best you got, especially if you're using like an older version or something. So hopefully that all makes sense. But for example, if you look at find git, it tells you example usage, and it tells you what it imports. So if you do that on this here, and I think actually we did do that on the CMake modules. Yeah, we do a find package git earlier, and that's essentially using this same thing. So if we wanted to make our own version of finding git, we'd put a module in here, and we'd design our own with find git.cmake. And then we could write our own code for where CMake is. Now, I would recommend just looking at some example of these. I don't want to write one of these, but just know that you can do it, and that's what it does when it's a module. So it does default to module, and if it doesn't find a module, then it goes to config. So in general, you just want to leave this blank, and that way it checks if you have a module. If you don't have one, then it just uses the default CMake config, which is whatever it has built in to do it. If you're using that config one, you want to look it up on here and see what it does. So for example, it gives us the git executable. Perfect. And that's what we actually end up using here. Git executable right there. See that? So we were actually already using this. I just didn't talk about it before. So that git one, it'll get you all this stuff. It sets all this stuff. And it, just like with GLEW, it tells you what all it sets. So there's a couple of variables you can set, and you just do those with the set, and then this, and then whatever you want to set it to. And it gives you the imported targets, like the shared libraries. So if this works, we could say, we could use this as the link library, and we could use all this stuff. We have the GLEW includers, the libraries, shared libraries, we have a found variable, we have the versions. So that's all what it brings in. So, all right, and if you do put module or config in here, it only does that one. It doesn't do the whole backup thing where it tries config or tries module first and then goes to config. If you type one in, it only does that one. Package CMake. Let's just Google this. Go to the top document, and let's just look at this real quick. So we're basically using the basic signature module mode, which is find package, package name, version. You can leave that blank and it'll just find whatever version, but if you know a specific version you need, you can put that in there. And then you can have exact or not. Then there's that quiet mode you can have. So basically these bracketed things are optional. And you can say module or config on that one. You can say required. And also there's components. So I don't think I'm going to talk about components, but you can read about it on this page if you're curious. And then there's optional components. And then there's a full signature mode, which has more options. And this is probably actually what we would need to do to get it to work properly for GLEW on Windows. Since we don't build it, we have to point to all the binary stuff with hints and paths, just like we did with Find Library. And I'm now going to remote connect to my Linux machine. And here we are. So I've commented out all the old stuff from the last video. And if we just put, like, for example, GLEW required, it will just work. We'll get everything. Of course, we could do modules if we want. So I guess as to another point, a lot of libraries don't have that config yet. A lot of libraries, whoever's developing doesn't have they don't have a config file in their code, but they should. GLEW here, just using it as an example. Here it is. So it's down in build, CMake. There's that. So that's what you need to point to with config. For that, if you're building it, but if you're not building it, you don't have to worry about that. Anything you build or have compiled on your own, you're going to have to do that for. All right, so let's look up another one. Let's look up, I don't know, let's look up GLFW, for example. That's another one we look at a lot. It's commonly used. So this will also have a CMake config somewhere in here probably. So if we search, we'll find config.cmake, and we should be able to find that somewhere in. I guess they don't. But let's see. Let's look at some boost libraries, and let's look at see if within here we can find a config.cmake. Don't think so. So not all libraries support this. This is something that should be in libraries, but is not necessarily going to be there. So you might have to just write your own find module. So I don't know, maybe let's look at SDL. SDL. I'm trying to think of another library. They've got CMake in here. I don't know. No, these are not configs. Yeah, here we go. Big. It's a .in though. I'm not sure exactly what this is, but this is basically it. Yeah, it'll see it just sets all the libraries. It sets all the properties for the libraries. So basically this, when you use this module, it just finds it and it sets it up for your project. Please like, comment, subscribe. It would mean a lot to me. And please do. Just do it. Just hit the buttons. I'm trying to think what else I should add here. I guess nothing. Let's just build this. I'm going to delete these SH files. I don't think we need them anymore. See what kind of error we get, if any. Let's do a build. Hit play, and it launches our window. So it actually works here. So our main is including GLEW and GLUT. I don't think we need GLUT. All right, so GLFW3 has all the OpenGL stuff, and GLEW is just an extension wrangler to call the OpenGL stuff. But with this will include the headers for OpenGL, so that's why we don't need to include GL. So we could essentially do something with OpenGL here now at this point. We just had some code, and I guess I could go find some. Let me go find some real quick. Please. This shouldn't be GLEW libraries, I don't think. Target link libraries should be GLEW libraries. So since we weren't using any glue stuff, that's probably why it wasn't having any problems. Let's just do a little Google foo. I found this gist. I don't know if this is good or not, but using glue and GLFW3. Let's just comment out all my previous code. I might put some of it back in, but let's just walk through this from the top. It includes glue and GLFW. Excellent. And we've got a print errors function. And we've got some defines for debug stuff. And we're on release, so we're not going to be using those. And our editor has gone ahead and grayed those out, so that's cool. Got another function here called print shader info log. All right. Then we got a main. So he declares a window, initializes the window, creates a window called hello world, makes the context current to that window, then does a glue init and makes sure glue is okay. And then let's see, he makes a vertex shader here and a fragment shader here, just some little basic ones there with the position and a color. And then he declares some vertices, probably just a triangle and some elements. Yeah, just a little triangle there. And then here we go. Here's a vertex array object. Getting into OpenGL stuff now. And he's using his check call function up here. Oh, this is just seeing what it returned basically. So it's mainly, that's the actual function. He's just wrapping it in a thing that's going to spit out what, a 1 or a 0, I guess, or whatever it returned, basically, something like that. And he's binding it. Okay, binding a vertex array object, and then a buffer object for all the actual vertices, then an element buffer for these elements here, or the indices. And then he's going ahead and compiling the shaders. So compiles the vertex shader, compiles the fragment shader, and then combines them into a shader program. And he has a position attribute for the shader. Not sure exactly what this is, but do something with it. Is it part of one of these shaders? Yeah, in vec2 position. Yeah. So that's just where he's pushing up everything, or how he's linking it to the shader, so to speak. And then we go into a while loop for GLFW, while it should close. And it looks like he's just going to draw and swap buffers, pull events, GLFW things. And then if that exits, he deletes everything and terminates. So it looks like this should work. I think this will work fine. So we were pretty close up here, actually. We just basically needed a glue init here. I'm not super familiar with glue. And, and check for errors. And then basically we could do stuff. So that's essentially what this code down here is doing. Let's see if it'll run. Build. I think it will. Well, this will tell us if glue is linked and included correctly, basically. So that's the whole problem. Is there's an error in this. Yeah. Okay. Yeah. There we go. Let's try that. Okay. There we go. Yeah, there we go. I guess I'll include that with it just for the heck of it. Yeah, I'll just fix this up and commit it. Well, that's going to be the video. I hope this makes sense with all this fine package stuff and modules and not modules. It's been awful confusing to get a video about it. I see why there are like none out there, because it's just so much to cover that how many takes would this take to get it right? A million. I'm just going to release this as it is. I'll try to edit it to make sense. Please show some support. Thank you.